Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, reducing dishes. So basically we have a chef that collected data on a satisfaction level of his dishes. And the chef can cook a dish in 1 unit of time, right? And then we have this concept of like time coefficient. It sounds a little bit complicated, but all it is the time taken to cook a dish, including previous dishes, multiplied by its satisfaction, right? So basically you cook the first dish at time 1, the second dish at time 2, the third dish at time 3, and so the satisfaction level of the third dish is 3 multiplied by the value in the satisfaction level array. So that's all what this means. And what we want is choose some subset of the dishes to do, and what we want is to choose it in a way that we maximize the sum of this like time coefficient that we defined as this for all of the dishes that we are going to choose, right? It sounds a little bit wordy and complicated, but with an example it will be a lot clearer. So what we get is a satisfaction array that says for each dish what is the satisfaction level, right? So that's the first thing, and we can skip any dish we want. We can also arrange them in any order, right? So we can choose to cook this dish first and then cook this dish second, right, for example. And why does it matter which one to cook first or second? Because we have the time that increases. So if we choose this one to cook first, then the time would be 1 and the satisfaction would be 5, so it would be 1 multiplied by 5. That would be the like time coefficient. If we choose let's say -8 seconds, then the time would be 2, because each time increases. You cook a dish in 1 unit of time. So when you cook a dish, for the second dish, the time increments by 1. And so when the time increments by 1, this would be a 2 multiplied by the satisfaction value, which would be -8, so it would be -16, right? So that's sort of the idea here. But for this case, the optimal thing to do is to choose dish -1 and cook that first, then dish at this one with satisfaction 0, and then dish with satisfaction 5. So these 3. And so that will give us -1 multiplied by 1, because we will choose to cook this dish first, and so time is equal to 1. Then we'll cook this one second, so time equal to 2 multiplied by 0. And then when we cook 5, then it will be multiplied by 3, so that's 14, right? So that's the total sum, and this would be, if you try other combination, this is the most optimal with value 14. The second example with this dish, since we can do them in any order, we can choose the smallest one first, right? So that we can maximize then the time that we multiply the biggest one with. So that would give us 2 multiplied by 1 plus 3 multiplied by 2. So time increments each time by 1, right? And then we multiply 2 by 1, 3 by 2, 4 by 3. And that will give us 20. So that's the idea. Now let's implement this and see how we can solve it. Okay, so how can we address this? So the first observation to make is that it's always better to cook the dishes with the smallest satisfaction value first. Why? Because as we go from dish to dish, the time increases by 1. So first is 1, then is 2, then is 3. And we want to maximize the total satisfaction, right? And each time we do the time multiplied by the satisfaction. Let's call it S. Let's call it S array here. Multiplied by the satisfaction level, right? And so let's say it's always better to choose the smallest value. Why? Because let's say between -1 and 5, which one is better to pick first? It's -1. Why? Because let's say you don't do that. You pick the biggest one first, just to demonstrate by contradiction, right? So if you pick this first one, the largest one first, then the total satisfaction would be 5 multiplied by 1 plus minus 1 multiplied by 2 because the time increases each time. And this will give you 5 minus 2, which would give you 3, right? But what if we did the reverse and then took minus 1 first and 5 second, then that will give us minus 1 multiplied by 1 plus 5 multiplied by 2, which will give us minus 1 plus 10, which will give us 9. So this is bigger. And so this contradicts the fact that we want to maximize the total sum, the total like time coefficient, right? So it's always better, with this contradiction, we can sort of get the idea that it's always better to choose the smallest value first. And intuitively it makes sense, because if you multiply a bigger time with a bigger number, that will give you a bigger total than if you multiply the bigger number with a smaller number, right? Because as time if you do 2 multiplied by 3, right, this is going to be better than 2 multiplied by 1, and 2 multiplied by 5 is going to be better than 2 multiplied by 3, right? Or than 1 multiplied by 3. So it's better to use the biggest time with the biggest satisfaction value so that you can get the biggest value possible. So that's sort of the idea first. And so what does that mean? So it's always better to pick the smallest value. Well, that means let's just sort the array first before even doing anything. So let's sort the array. And so what we can do there is just sort it so that we get minus 8, minus 1, minus actually 9 first. So that would be minus 9, and then 0, and then 5, right? Okay, so that's the first observation. Now from there, what should we do? So we can definitely think about a greedy strategy to solve this, but let's start first from the easiest option, which is let's just try all of them, right? And see which one is better. So how does that work? Well, let's just start from the first, taking this sorted array here that we sort first. Let's just start from the first index here. So the indices are 0, 1, 2, 3, 4, right? So if we choose first, we have 2 choices for each element. Either take it, right, and cook that dish, or don't take it and don't cook that dish, right? So for example, when we are considering index 0, so first we can either, for index 0, we can either choose to take it or not. So if we take it, and so here, let's just mark not taking it with D. Then here, if we take it, we would have, what's the total? It would be 0, it will be minus 9 multiplied by 1. So minus 9. If we take it, if we don't take it, we still have 0. And then we keep recursing from that tree. From minus 9, we go to the next one. Should we take it or not? So we try the both. So if we take it, it's going to be minus 8 multiplied by 2, right? Because time increases each time, right? So each time we start from 1, we go to, it's 2. And so here, if we take it, then this is going to be minus, it's going to be minus 16, right? And so we add that to 9. It's going to be, sorry about that. It's going to be 25, right? So we have minus 25. And then not taking it would be just, we stay at minus 9. And again, we go to the next. And then we try both take it and don't take it. We go here, we try take it and don't take it. And same thing for initially, if we didn't take minus 1, for 1, we choose either to take it or not take it. If we take it, then it's going to be minus 1 multiplied by 1, because this was the first dish we cook. So it would be minus 8. Or don't take it, we have 0. And now we go to 2 and take it or don't take it again. So you get the idea. We explore all the tree branches, and at the end, we'll get that the max value is going to be minus 1, 0, 5, right? So that's the simplest way to do it, is just to explore all branches, and each time, basically, you have only these 2 choices. If you take it, then you are going to multiply the time by the satisfaction at I, and then we are going to recurse, right, on I plus 1 and T plus 1, because we go 1 step down, right? And then here, if we don't take it, then we just recurse on I plus 1, and the time doesn't increase in this case because we didn't use it. And then we pick just the max between these 2. right? And so this is really like just using sort of a brute force way here. Let's first implement this approach, make sure it passes, and then we can think about a more sophisticated version. Okay, so let's implement this solution. So what we need to do first is we need to take the satisfaction array and sort it, right? And so we sort our array first. And then we have our function that will recurse on I and t, right? So we need the index in satisfaction array and we need the time, the current time. Now what is our base case? Well, it's when we reach the end of the satisfaction array, so no more dishes. In that case, we can just return the base, which is value 0. But otherwise, we just have two choices, take it or don't take it, and we consider both. And we take the max, right? And so for take, what is it going to be? It's just going to be satisfaction at I multiplied by the value of t, which we increase each time we take, we increase it, plus the helper, plus the recursion, we recurse on the to go to the next dish, and we increment time by 1 because we just used 1 unit of time to cook dish I. You can say this is take or cook dish I, right? Skip dish I, right? And then if we skipping, well, we go to the next one, but the time doesn't increase because we didn't use a unit of time to cook the dish, right? And then we return this, and then we start our recursion with from the first dish, and then time starts out as 1, right? And that's sort of the idea here. So let's run it first on the examples. Looks like here we need, because we are taking the max, we need a comma. It looks good so far. Now, to prevent this from giving us a time limit exceeded, we need to memoize, right? So that if this gets called, one of these gets called with the same parameter multiple times, we don't recalculate it each time. So to do that, we'll just have a memoization table and then check if both the two parameters or the state are in memo. That means we already calculated it, so we just return them. Otherwise, we set it as that and then we return it. Okay, that should be good. Let's submit. And this passes our test cases, okay? Okay, so that's the first sort of naive solution. Now, can we solve it in a better way? Okay, so now for this next approach, let's make one more observation. So we want to maximize the overall, time coefficient, right? Overall, like time coefficient, right? What we can do here is that we will cook the dish with the smallest that's what we agreed on. We'll cook the dish with the smallest satisfaction first and then leave the most satisfied dish to the end, right? That way, basically, we multiply the highest satisfaction value, like 5 here, with the highest time possible. That's what we want, okay? And so how do we do that? Well, we can either do the approach where we go forward, right? So we go forward in the time. So for example, here we go forward in time, right? We start out first with this one with value 1, and then this one with value 2, 3, 4, 5, right? And then when we get here, we need to multiply the time, which at this time maybe would have been 5 or 4, and then we multiply it by 5, right? So that's possible, and so that we will end up with maybe something like 4 multiplied by 5. But what is 4 multiplied by 5? So this would be t multiplied by the satisfaction. Well, this is just 5 plus 5 plus 5 plus 5, right? And the same thing here, just s of I, t times, right? T times. Okay? And so the idea here is, let's go backwards in the array. So for example, in our array -8, -105, let's actually go backwards like this, from 5 to 0 to -1. And because we want this 5 to be multiplied by as many times as dishes we cook, every time we cook another dish, we'll add this 5 again. And that basically will make it so that we added t times, right? So let's say in the winning case here, where we will cook only these dishes, what we'll do then is we will say 5 plus 5. First, when we process this, we will add just 5. And then when we are processing this, we will add 5 again. When we are processing this, we'll add 5 again. Now for this 0, it happens to be 0 here, but if it was 2, for example, we'll add 2 here, and then we'll add 2 here. And then we'll add -1 once. So in this case, what happened? We added 5 3 times, we added 2 2 times, and -1 once. And so this event essentially is going to end up like 3 multiplied by 5 plus 2 multiplied by 2. This is supposing we had 2 here. And then plus -1 multiplied by 1, right? And now what is this? This is actually just if we had time, t equal to 1, t equal to 2, t equal to 3, then we are going to end up with t equal to 1 multiplied by -1 plus t equal to 2 multiplied by 2 plus t equal to 3 multiplied by 5. So it's the same outcome, right? Except here we are doing it by each time we put the value, we will keep adding it every time we pick a dish going backwards, right? And so that will give us the actually the same outcome, okay? So that's the idea here of this solution. Now, the question becomes, how do we get the optimal value? Well, what we want to make sure we are doing is that we want to make sure that we don't reduce the sum we take. So if taking -1 will reduce the overall sum, we should not take it. That just makes sense. If taking -8 will reduce the overall sum, we won't take it, right? So let's apply it on this example with this array here. What will happen here is that we sort it first and we go backwards, right? And so we need to keep track of an accumulative value that will just keep track of the accumulative sum so far, so that we can add each of these, the number of times we need to add it. And then we'll need a final result, right? And then we will need to know when we need to stop, right? And so let me just have accumulative value here. So first we are at 5. And so we check, is 5, accumulative is first. So we check if accumulative plus 5, if that's going to be bigger than 0. Because if it's going to be smaller than 0, right, then if we add it to our overall result value, it will make it smaller. So we don't do it. And so that means here our check is going to be while, of course, the list itself is not empty, and the accumulative value plus the value we are looking at, I will show you how we can do this, is bigger than 0. Because if it's smaller than 0, that means the result would be reduced if we add it, and so it would be smaller. But we want to maximize it, so if it will make it smaller, we won't take it. We won't take the dish. Now, since this is a list like this, we can either keep an index or we can just pop the element, because we are going backwards, and once we process an element, we will no longer go back to it. So we can each time just look at the last value, because we will remove any value after we process it. And so here first we'll process this 5, right? And so we will add it to our accumulative value, right? And then we will add it here. And now we pop it off, and we go to the second one, and so we add it to our accumulative value. Now it's 7, and so we add this 7 to this result. Now you may say, why add 7? Because remember, this would mean we added, if we add 7, it would mean we added 5, and then we added 5 again, we added 2. And that's exactly what we want. We want to, each time we process a new element, we want to add all the dishes that we did before, we want to add them one more time, right? And so basically what this is accumulative value is going to be equal to, each time we'll add the satisfaction value we just popped, right? Which basically is the latest we are going backwards. And then we will add to result that accumulative value. Because remember, result is all of these. And so each time we process an element, we want to add one more time all of those that appeared before it, right? So that we can get the time multiplication here. Okay? And so now our result is going to be 5 plus 7, which is 12. Which is 12 here. Sorry about that. So here it's... Okay, let me... 1 second. Let me just move this down so that we don't keep... Okay. So now what we'll have here is that result is going to be 7 plus 5, which is 12, right? And then we will move again, so we'll pop this 2, we'll move here to -1, and we check is accumulative value, which is 7, right? 7 plus the lightest one, which is -1, is 6. It's still positive, so we are still good to go. And so we add -1 to our accumulative value here, and so it becomes 6. And then we add 6 to 12, and this will become 18. Now, why is this 18 in this case? If we map it back here, well, it's 18 because it's 5 plus, because we processed 5, the previous dishes before -1 are 2 here. And so it's going to be 5, this one from processing -2, this one is from processing 5, and then another 5 from processing -1. For 2, it's 1 from processing 2 itself, and then 1 from processing -1. And then -1 is just once, right? So this will end up being 3 multiplied by 5, 2 multiplied by 2, and then -1. And so there you can see this is the time, this is the time, this is the time if we were going forward. Okay? I hope this makes sense. And now we are, if we go, now this is removed, so we go to -8. Now what is, the accumulative value is 6 minus 8, that's going to be -2, right? So -2 is negative, so it's not bigger than 0, so we stop, and this is our result, 18, right? And so this is the idea of this solution. It's pretty clever. Instead of doing the multiplication, we just go backwards, and each time we add it until we get the multiplicative that we need to add here. Yeah, that's pretty much it. And the result is going to be end up being the entire sum. And that's pretty much it for this solution, right? So let's implement it and make sure it passes our test cases. Okay, so let's implement the solution the other solution we just saw. So we still need to sort the satisfaction array, but we need 2 variables. We need our result and the accumulative value. Both start out as 0, and we need to keep processing until either there is no element in the satisfaction array, or the last value plus accumulative is going to be less than 0. If it's less than 0, we don't want to add it to the result because it will make it smaller, which will mean it will make it less optimal. And so we only process it, we only cook the dish if the value we get from it is going to be positive. So our accumulative value each time is just going to take the biggest, we are going backwards, so each time it takes the bigger satisfaction value. And then res is going to be just the sum of the accumulation. And this is exactly what we did in the overview. And then at the end, we return the total result. Okay, so let's run this, let's submit. And yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.